Before we start doing calculations, we need to look at numbers and decide which digits count as significant figures. There are longer ways to state the rules, but here's a simple way. Significant figures are all digits except leading zeros and ending zeros with no decimal shown. Okay, so let's go through and look at these. If you have digits that are non-zero, they always count. So those all count. These zeros that are sandwiched are not leading or ending, so they count. These are what we mean by leading zeros. They never count. It doesn't matter where the decimal place is up here. None of those count. So these two count. Here's another one with ending zeros, or here's one with ending zeros. Because it has a decimal shown, we see the dot. This counts. Here's a complicated one. These leading zeros don't count. This sandwiched zero does. It's not leading or ending. This one has ending zeros. There's a decimal point shown though, so these do count. Here's one with ending zeros and no decimal point shown, so it has only one. If this number had been written like this with a decimal point shown, then all four of those would count, ending zeros with a decimal point shown. Once we can count them, we can do calculations and round our answers properly. When you multiply or divide, you look at the numbers going into the calculation, and the one with the least sig figs tells you how to round your answer. In other words, this top number has 5 sig figs. The bottom number has 4. So our answer is limited to 4 significant figures because of the bottom one has the least. So to write this with 4, remember the 0 is leading, so it doesn't count. So it has 4 significant figures. Be sure when you write numbers, you always write units with it. So we get the units from right there. When you add and subtract, you look at how far the digits go to the right, and we'll be practicing that a lot as we do these example problems, so we'll see about that. Okay, and then just an introduction to how our experiment will work. In particular, how are we going to get the volume of our flask? So one thing we're going to do, this flask is, I believe it says a 25 milliliter flask, but you need to know that's not the real volume of this flask. We call it 25 milliliters, but we need to know the volume all the way up to the top. And these flasks aren't, this kind of flask is not made to have a set volume. So to get the real volume of the flask, what we're going to do is we'll weigh the fat flask empty with its stopper, and then we'll fill it with water, and then we'll weigh it with water. We will then know how many grams of water there are, and using the density of water, we will be able to calculate the volume of water. Once we have the volume of water, that is the same thing as the volume of the flask. Once we get the volume of the flask, we can fill this with other things and do calculations from that.